Hello everyone, welcome back to my channel, and on today's topic we are going to discuss about Java data types. This is like a tutorial, and I've tried to include some code working at the end of this tutorial, so it will be helpful for you guys. So let's get started. So what is Java data type? Data type specify the different size and values that can be stored in variables. Simply it defines how to store the value of different variable, and the use of data type is the proper data representation, proper memory allocation, proper operation to be performed. And there are two types of data type in Java. It's primitive data type and non-primitive data type. And to talk about primitive data type, the primitive data type includes boolean, character, char, not character, char, byte, short, int, long, float, and double. While there is non-primitive data type, that includes class, interface, arrays, and string as well. So to talk about primitive data types, in Java language, primitive data types are the building blocks of data manipulation. These are the most basic data types available in Java language. And in Java, there are mainly 8 primitive data types, and these are the 8 primitive data types: boolean data type, byte data type, char data type, short data type, int data type, long data type, float data type, double data type. To talk about boolean, it's just true and false. For about byte data type, it just stores 8 bits of data, while on char it stores 16 bits of Unicode character. Like on shorts, it stores 16 bits of numbers from ranging from negative 32,768 to positive 32,767. So here are the list, and let's talk about non-primitive data type. Non-primitive data type in Java, non-primitive data type are also known as reference data type and are used to store complex objects rather than simple values. Unlike primitive data type that store the actual value, reference data types store references or memory addresses that point to the location of the object in memory. This distinction is important because it affects how these data types are stored, passed, and manipulated in Java program. And let's see how non-primitive data type works. And first we're gonna discuss about class in non-primitive data type. One common non-primitive data type in Java is the class. Classes are used to create objects which are instances of the class. A class defines the properties and behavior of objects, including variable and method. For example, you might create a person class to represent a person with variables for the person name, age, and addresses, and methods to set and get these values. And let's talk about arrays, because arrays are on number second as non-primitive data type. So arrays are a fundamental non-primitive data type in Java that allow you to store multiple values of the same type in a single variable. Arrays have a fixed size, which is specified when the array is created, and can be accessed using an index. Arrays are commonly used to store lists of values or to represent matrices and other multi-dimensional data structure. And on number 3, we're going to talk about enum. So Java also includes other non-primitive data types such as enums and collections. Enums are used to define a set of name constant, providing a way to represent a fixed set of values. Collections are a framework of classes and interfaces that provide a dynamic data structure such as lists, sets, and maps, which can grow or shrink in size as needed. So overall, non-primitive data type in Java are essential for creating complex and flexible programs. They allow you to create and manipulate objects, define relationships between objects and represent complex data structures. By understanding how to use non-primitive data type effectively, you can write more efficient and maintainable Java codes. For example, I've given these are the data, like these are the basic data I've just given. So as in data, first name I put John, last name Smith, age 22, phone number blah blah blah, height 5 feet 6 inches, gender male, as in M. So here first name John and the second name Smith, right? So that means it's a non-primitive data type, as it means string. So on age, it's a primitive data type because it includes the integer. And on phone number, it's a primitive data type as well, like as in int. And on height, I've included like a primitive data type because it's a double, because it has decimal value. And on gender, it is like a primitive data type because character, M is a character. So anyway, after this example, we're gonna talk about typecasting in Java. So what is typecasting in Java? Typecasting in Java is a fundamental concept that allows developers to convert data from one data type to another data type. It is essential for handling data in various situations, especially when dealing with different types of variables, expression, and method. In Java, typecasting is a method or process that converts a data type into another data type in both ways, manually and automatically. The automatic conversion is done by the compiler, and manual conversion is performed by the programmer. Let's see the hierarchy of this typecasting. So at first, double is changed into float, and float is changed into long, and long is changed into int, and int is changed into short, and short is changed into byte. So that is called narrow typecasting. So it goes from double, float, long, int, short to byte. And if that goes opposite, for example, byte to short, short to int, int to long, long to float, float to double, that's called winding typecasting, which is implicit typecasting as well. And let's talk about narrow typecasting or explicit typecasting. So narrow typecasting requires explicit notation using parentheses and casting. Conversion from a larger data type to smaller data type is allowed. Risk of data loss is due to truncation. So let's see the hierarchy here. So it goes from double to float, float to long, long to int, int to short, short to byte. And that's the process, how it goes from bigger to smaller. And in this process we can lose some data, yeah. So that's called narrowing typecasting. And now we're gonna understand the scenario scenario about winding typecasting, which is implicit. So no explicit notation is required. Conversion from a smaller data type to a larger data type is allowed. No risk of data loss. So let's see the hierarchy here. So you got byte to short, short to int, int to long, long to float, float to double. So that's how it goes, and there is no chance of losing any data. And on next slide, let's talk about Java wrapper classes. So each and every primitive data type has its own respective class, is known as wrapper class. Wrapper classes provide a way to use primitive data types as objects. And let's see the chart. So here you go, that's a primitive data type on the left hand side, while that's a wrapper class. So the wrapper class is always on capital letter, while the primitive data type are in small letter. And let's go to another example. Here you go. So I've created a class called test, and integer my int as like what is that called, wrapper class, as integer wrapper class. So I've given value 100 here on my int, and I've changed that integer to string. So here you go, string as in my string, and I've converted that my int to string, and that is stored in my string. And I'm gonna decide, I'm gonna check how many the length of this my integer. So I've printed out the length, and the outcome should be 3. And on next slide, let's talk about autoboxing and unboxing. The automatic conversion of primitive data type into its equivalent wrapper type is known as boxing or autoboxing, and the opposite operation is known as unboxing. In autoboxing, primitive data type are changed into wrapper class, which means variable are changed into object. In unboxing, wrapper class are changed into primitive data type, which means object are changed into variable. For example, autoboxing, here the integer it's like around ones, tens, 100,000, 10,000, 100,000, million, 10 million, 100 million. I've given integer my int 1 as 100 million value. So I've changed and I've created another or integer wrapper class called my int, and on my int I've put the value of integer. So this integer wrapper integer my int hold the value of integer my int 1, and I've changed that my int into string, like my string, and then I've tried to check the length of that string. Alright, so that's how I'm doing autoboxing here. And the output should be 9. Yep, 9. And let's check the example of auto unboxing. So I've given this I've created this test class here. So I've got like this wrapper class integer my int. I've given value of 10,999, and I'm getting integer here my int 1, and on my int 1 I've got the value of integer my int, and I'm printing this integer. It will just give me this same value. Let's see the output. You can try this one on your Java IDE as well. And on next slide, if you got any questions, you can feel free to comment, and I will try to comment back. And thanks for watching for now.